Okay, so yesterday's fun was learning whole numbers versus integer versus rational numbers and putting numbers in order. Today we're going to talk about opposites, absolute value, and conditional statements. Opposites in math is going to mean two numbers that are the same distance from zero on the number line, but opposite sides. So if you envision the number line and you have a zero in the middle, over here you'd have a 2. Going the same distance in the other direction, you'd have -2. So basically it's going to be the positive and the negative of the same number. So if I had 0.71, its opposite would have to be -0.71 because they would be the same distance from zero, just going in opposite directions. So kind of get that through your head. If you ask for the opposite of a number, you're going to change the sign. So you're going to change it from plus to minus or minus to plus. Okay, absolute value. You might have seen this before, possibly not. Absolute value is going to be these bars. And if you see the absolute value around a number, it's asking the distance between that number and zero. So it's asking how far away from zero are you? And even if you are 2, you're going to say you're 2 away. But even if you are -2, those bars are asking how far away from zero are you? And -2 is also 2 units. And so the beauty of absolute value is whatever's on the inside is always going to come out positive. Because it's asking a distance, so it's going to be a positive distance. So if you go 5 miles east or 5 miles west, it doesn't really matter which direction. The distance you went is 5 miles. Same with absolute value. 2 to the right, 2 to the left, you're still 2 units away from zero. So our last vocabulary term is conditional statement, and this is going to get you ready for geometry and just kind of thinking about math statements. So a conditional statement is kind of like when you say, well, there's conditions. If you want to go do something and your parents say you have to do something else first, if you clean your room, then you can go to the mall. That's a conditional statement. It's a statement that has a hypothesis and a conclusion. That is fancy terminology for the if and the then. So if you clean your room is the hypothesis, and then the then part where it says then you can go to the mall, that's the conclusion. So you're going to have your if, then your hypothesis, which would be clean your room, then, and now the conclusion, you can go to the mall. But they're going to be math statements, but they're going to be if-then statements. So not a lot of calculation again today. We're just going to be doing some thinking and kind of remembering what those new terms mean to us. So you'll be asked to find the opposite of the number. And so just think to yourself, that means I need to change the sign so that if it used to be on the right of zero on the number line, now it's to the left, and so on. So if I take a look here, it's asking me if A is -48, then -A. Now be careful with that, because when you see -A, that means the opposite of A. So for example, here, the opposite of A, you would think from looking at this that it would be negative, but it's telling you to take the opposite, which is here, of your A value, which is going in here. But your A value in this case happens to be a negative. So those negatives cancel out, and your end result is a 4.8. So that makes sense though, because if I look at it here, it's saying if A is -48, what's the opposite? Well, the opposite of -48 would be +48. So you do have to do some thinking about the negatives, because remember that a negative times a negative becomes positive, so they'll cancel out. Here it's telling you that A is +5/6. So then this is asking for the opposite of that, which would be -5/6. So still 5/6 away from zero, but going in the opposite direction. All right, so let's take a look through. This is that absolute value. So keeping in mind that absolute value is going to be the bars that go around it. Anything that comes out of the bars will be positive. So and this is an if-then statement, if x is a positive number, then the absolute value of x is x, meaning the same thing that you put in the positive of it. If x is 0, then the absolute value of x equals, well, think about it. You're asking with absolute value how far away it is from 0. So how far is 0 away from 0? 0. Okay, so the last situation there is, what if x is a negative number? Then the absolute value of x will be not negative. That doesn't look like, it looks like a negative sign, but that's not what it means. It means it will be the opposite of x. So that's all really wordy and kind of tricky. What you want to remember is that this is always asking how far away is that x value from 0. So my answer for anything coming out of the bars is going to be a positive answer, because you're telling you how far it is. So this one's asking, how far is 5 away from 0? 5 units. The second example is asking, how far away from 0 is 0? 0 units. This last one is asking, how far is -4 from 0? Well, if you were to draw out -4 on the number line, here's 0, 1, 2, 3, -4. How far is that from 0? 4. So this opposite thing might mess your brain up a little bit if you're thinking of it as the opposite of a negative. But just kind of think, how far is that number from 0? 4 units. The only reason the negative matters is it's telling you which direction it's 4 to the left. Okay, so take a second to try to figure out, what would the answer to part A be here? If you're looking at A is -3/7, it's asking for the absolute value of -3/7. Now, if you can just go right to the answer, what would your answer be? +3/7. These other parts are just showing you how to write it out, but if this is actually confusing you more, you don't have to write each step along the way. This is saying, okay, this is the absolute value of -3/7, which means to take the opposite of it. I think this step sometimes is confusing, and you're better off just remembering that this is asking you how far is -3/7 from 0, and then you can go right to your answer. How about in B? B is asking us to take the absolute value of 2.9. So it's saying, how far is 2.9 from 0? Well, that's still 2.9 units from 0. So one mistake that kids make is they think that a positive becomes negative, but that's not the case, because it's still asking, how far are you from 0? So everything that's coming out of the bars will always be positive, whether it started out positive or negative. Okay, so let's take a look at analyzing a conditional. That sounds really smart. We're going to analyze a conditional statement. Keep in mind, a conditional statement is really an if-then statement. And so when it says identify the hypothesis, we'll go ahead and highlight the hypothesis in yellow, and then we'll highlight our conclusion in pink. If a number is an integer, then the number is positive. Okay, so your hypothesis is always the if part. So that would be, for us, a number, oops, forgot to change the color, sorry. A number is an integer. So if a number is an integer, then, now our conclusion would be, the number is positive. So just because you've made a conditional statement doesn't mean it's true. This is saying, tell whether the statement is true or false. If it is false, give what they call a counterexample. A counterexample means you say, that's not true because I can think of this number that is an integer but is not positive. So think back to what we talked about with integers. When we listed the integers, We listed 0, 1, 2, 3, and so on, but that was whole numbers. So we also included for integers the negative values. So reading this, if a number is an integer, then the number is positive. Well, I'm going to go with false on that one because that leaves all the rest of these numbers out that were on our integer list. So let's see how we did here. What's the hypothesis? The part that follows if, so the beginning. If a number is an integer. So keeping in mind, that's my if part. My then part should be the conclusion. So see if we got that right. The number is positive. Awesome. So we have to come up with a counterexample since we chose false, or at least I chose false. It tells me that if the number is an integer, then it is positive. I would say that's false. My counterexample could be like -2. -2 is an integer, but it is not positive. That is one of many, like an infinite number of right options. I could have chosen -1, -2, -3. Any negative integer would be a good counterexample for this problem. So we were right, it's false, and then they chose -5. That doesn't mean I'm wrong to choose -2 as my counterexample. It's just a different counterexample. Okay, so let's go through here. It says for a given value of A, find the opposite. So we're doing two things. We're practicing two things. Find the opposite of A and find the absolute value. So we're going to do both of those things. Okay, what is the opposite of A? Would be the opposite of a +6 would be a -6. What's the opposite of this A? What's the opposite of -9.5? Well, I would say my answer is +9.5 because you want them to be opposite in sign. What is the opposite of -3/8? Don't get all confused by the double negatives. Just think the opposite of a negative will be a positive. The actual value of the number never changes. So then let's go through and do our absolute values. What's the absolute value of 6? So you're asking yourself, how far is 6 from 0? My answer would be 6. How about here? How far is -9.5 from 0? Well, 9.5. And lastly, how far is -3/8 from 0? Well, that's going to be 3/8 to the left, but it's still 3/8. So you can see that sometimes the opposite and the absolute value are the same, and sometimes they are not equal. So it's not going to necessarily be true that they are always the same or never the same. You have to take it on a case-by-case basis. All right, so let's take a look at this last example. It says, identify the hypothesis. So let's go through that again. We'll highlight our hypothesis in yellow, and we will highlight, our conclusion in pink. Tell whether it's true or false. So we'll do that. And if it's false, we're going to give a counterexample. Okay, so let's find our if statement. The words that follow the if statement will be our hypothesis because this is going to be our if and our then. If, so here comes our hypothesis, a number is negative, that's the hypothesis, then here comes the conclusion. The absolute value of the number is negative. If a number is negative, then the absolute value of the number is negative. Well, let's try an example. When you're doing a counterexample, you always have to pick a number that matches this first if part. So if a number is negative, let's just choose -2. Then the absolute value of that number is also negative. Well, that would mean if we picked -2, then the absolute value of -2 would have to be a negative answer, but it's not. So this must be a false statement, and my counterexample that I'm using is -2. because -2 is a negative number like the hypothesis says, but the absolute value of it is not negative. So I'm giving a counterexample. I'm saying, nope, you're wrong because what you said doesn't hold true for every number. They gave the answer you can see here, or excuse me, the example of -3. They said, well, -3 is a negative number like the hypothesis, but the absolute value of it is a positive number. In fact, the absolute value of everything is a positive number. So you're never going to have a situation where the absolute value answer comes out as a negative number. Okay, so I'm going to give you your homework assignment, which I unfortunately left upstairs. So I'm coming upstairs to get it. And you can hear some football in the background. Okay, so this is our 2.1, day 2. And you're going to be on page 67, which should sound familiar because that was yesterday. That's why this is called day 2. 2, 4. Then jump to 20, 24 through 28. But for those, you're only going to do the evens. 36, 38, 39, 40 through 50 even. And I know this sounds like a lot, but they go really fast. Then 56, 58A, and I think that's it. I cut out a bunch towards the end, but none of them are on your homework check, so you should be good to go. All right, have at it, guys.